All right. So I'm probably gonna ditch the first recording, so I don't have to make another one. You have to watch them in sequence. So just to recap, this is what we're trying to design. We're trying to model a basically employee hierarchy, and job is the most generic job, and then we get further specializations as we go down. So tech job does everything a job can do. Manager does everything a job can do. Front developer does everything a tech job can do and a job, and so on. And then finally at the bottom, the kind of leaf node of this hierarchy, we have a lead engineer at a startup who does everything that a front end developer can do and everything that a scrum master can do, and so on. Okay, so we've got this in code now. Let me come back here. So we have our hierarchy, we have our plan, we kind of know what we want to do, and now we want to implement it. But before we implement it, we want to write tests to make sure that as we're writing our code, we're not just testing like one-off things. We have a complex system, so we don't want to introduce what are called regressions. So a regression is a term you may hear. A regression is basically like I get one thing to work, but then it breaks something else somewhere else. So you want to avoid that. So we can just write a description. We can use tests to write a description of what this should actually do. So as we're developing, we can be sure that it works. We're going to use the built-in standard library unit test to make a lot of the boilerplate easier. You don't have to do this. You can, there's lots of different ways to write tests, but this is kind of an obvious choice. So the way that this unit test library works is we're going to inherit from unit test dot test case. So this is the kind of base class, and I can actually jump in here and we can look at the source code real quick. So I'm gonna let's see. So the way I did that is I'm on a Mac, so I type Alt or Option, and then I can click on this, and it jumps to the source code here. So you don't have to understand this, but this is like, actual Python code, like in Python itself. And we see that it's a class. It's a class called test case, and it inherits from object, which is basically like the topmost category. And here's a doc string describing what this class does. A class whose instances are single test cases. By default, the test code itself, blah, blah, blah. So there's a whole bunch of stuff which you don't need to look at. You can see here are a bunch of class variables, and then we have the init. So this is, more complicated init, and then a whole bunch of methods. So setup, tear down. We've seen an example of this. And let's see. See if we can find. We have all these assert statements, which are built in. So we're going to end up using these too. But we're going to get all this stuff for free because we're inheriting from this base class. And I'll just do pass for now. And then to make sure that it runs properly, we're going to do this if main equals main. This is basically boilerplate that you'll see in a lot of Python code. And it basically just says, if you run this file directly, do this. So you can also have modules that you import that you don't really run directly. You just kind of use the code. In this case, we're saying, if you do Python test.py, if you run this file directly, then this code will run. So unit test dot main. So this is the basic boilerplate that you'll have anytime you write a unit test using this unit test library. And the way that this works, you have to follow a certain convention in order to benefit from this. So this is just something you'll have to learn by looking up the documentation. So you can do that here. 1 second. So here's the official documentation for unit tests. So you can go here and look through this. The official documentation for Python is pretty good, but depending on what you're doing, it may be a little overwhelming. So you can use whatever resource is easiest. But here's very nice. They give you a basic example, and you can see that a lot of the boilerplate is the same. You import unit test, you create a subclass, which inherits from unit tests test case class, which we just looked at. And then at the bottom, you do this. And then all the tests that you write, you'll notice the tests have to start with test underscore whatever. So that's just the way this particular thing works. There's nothing like logically compelling about it. It's just how this works. So all the tests that we write are going to start with test underscore, and then we write our test case. So assert equal, assert true, assert false. There's all these different flavors of assert statements that you can use. All right, so I'm going to go back to the code here. So def test underscore what? So this is the unit tests for something like this are maybe a little difficult to think about, because what we really want to test here is just the structure of everything. We're not really doing anything too interesting at this point. So I'm basically going to test that whatever we write fits into this hierarchy. So I'm going to do test job. Actually, yeah, test job lists, something like that. So what I'm going to do is I'm going to create an instance of the job class, which we haven't written yet. Job equals job, and then self dot assert. And then the question is, what kind of assert statement do we want to use? So what I'm going to assert is that job is an instance of job. So that's kind of a, tautology, right? But I'll just do it anyway, and we'll see that it'll make more sense with the other ones. But assert is instance. I can do that. Job. And where is this stuff going to come from? That's going to come from this. We haven't written anything here, but that's where it's going to come from. So I'm going to import everything. So from jobs, imports, and I can use this asterisk, which basically means import everything. So we're going to have to write this first. So we have our initial test for job, and it's obviously not going to work because we haven't written the code yet. So let's write the code. So I'm going to do class job pass. So this is a minimal definition of a class, which does nothing basically. So now if I run my tests, Python tests.py, it passes. All right. So let's just kind of knock these out. This is pretty boring, but a lot of repetition. So def test tech job is job. And then I will do tech equals tech job self.assert instance. Job. So what I'm saying is here is that a tech job should be an instance of job. So now I can go back here and I can write class tech job that inherits from job. And I can do the same thing here. So this is just the minimum that we need to do to get this test passing. So now I'm going to run this test and it passes. All right, so I'm going to keep doing the same thing. Test the developer is job. So actually, I'm gonna do a couple tests. I'm gonna combine them to save myself some typing. So self.assert is instance. So this has to be, so front-end developer has to be an instance not only of job, but also tech job. So I'll start job, and then also tech job. Okay, so this test is going to fail. So I'm going to write some code to make it pass. Class front and developer, and that will inherit from tech job. So now I'm going to run my tests again, and my test pass. I'm going to go back here, and then I'm going to work my way over here as well. So manager. Self.assert is instance and job. Okay, that test will fail. I can just run it to make sure. Okay, that fails. So now I'm going to go over here. Last manager from job. All right, so that test passes now. So now Scrum Master also has to do the same thing. If anyone has any questions while I'm kind of doing this, just feel free to ask. So test.
Hey, Jed, so I see there's a third parameter called message, MSG. What's that used for? It doesn't tell me in the docs.
A third parameter?
Yeah, for the assert is instance.
Oh, I
So
see. Yeah, so here's so you can actually write a doc string here. So this is called the doc string. You can do so in here, for example, you could write a description. So tests that manager inherits from job. And let me make this clear. So when the test fails, you can see that this displays. So if you have lots of different tests, it's helpful to know, like, quickly you can see, okay, here's the test that failed, and here's what it was supposed to do. Test that manager inherits from job. So you can do that. You can write a doc string, and then the base class will pick that up and display it as output. Was that your question?
Um,
Or is there a parameter here?
yeah, there's a third. So for like right after job, there's a third parameter. It's called MSG.
Oh yeah. Uh yeah, I actually don't think I've used before. Let's see what it does.
Okay. This one says it's like MSG equals. They just have none here.
Mm, so I get that is printed out right here. So it looks like it's just another way for you to kind of give yourself or whoever else is running these tests something. So let's see what happens if it passes. It still displays that. No, it doesn't. So it looks like it's just another way to add more information that'll display if the test fails.
Gotcha. Okay, that's pretty slick. Cool,
Yeah.
thanks.
So this might be so like right here, for example, you can actually have multiple assert statements inside of a particular test. So you might want to have a general information about the test, but then this specific one, maybe like here's a specific edge case. So, watch out for, zero division or, whatever this particular assert statement is doing. All right. So the Scrum Master. So assert. Um, and then also, so assert is instance. Oops, let me do that. Also need to be an instance of manager. Okay, so that test will fail. And run it. Now I'm going to add that.
So is this completely separate from like production level error handling?
Yeah, yeah. So unit tests are basically they exist to test. There's different kinds of tests. So unit testing is the lowest level of testing. You're testing each individual piece of the code, and then you have uh, integration tests or component tests, which could test multiple like larger chunks of the system, and then you have end-to-end tests, which would be the full system. And there are different ways and different ways of doing each one, and different challenges involved uh, with all of them. So yeah, we're really just going to focus on unit tests here, because things start getting more complicated as you have to do other things. But that yeah, and then so like all of those tests are really like before you push your code to production. Those are all the tests you want to run. You want to try to make sure that you don't have bugs. That's not practically possible, but you want to minimize that. And then if there's a bug or like an error or something happens in production, usually there's logging and messaging and like monitoring tools and stuff that can let you know.
Okay, cool, thanks.
All right, so let's see if this test passes now. It does. All right, so last test. In here. So this is gonna have to be everything basically. Job, going to be job, it's going to be tech job, and manager, and developer, and Scrum Master. So this test will fail. Now I write some code. And that's going to inherit from, it has to inherit from these two things. So front and developer and Scrum Master. Let's see if the test passes now. And that passes. So, we've just done the initial boilerplate, but we can, since we've written tests that kind of describe everything we want to do, like nothing we do should really break this. So now we have scaffolding for what we're about to write, and we also have evidence for other people, and kind of this is like stored in the code base. Anyone can run this test. So if I were submitting a PR and someone were to review it, they could look at the unit test and say, oh, okay, these tests look good. So if this code passes all these tests and the tests look good, I probably don't even really have to look at the code, right? I know that that the tests are well written and that the tests pass, so that's probably good enough. Okay. Any questions about that so far?
I guess I'm just curious, Chad, if there, let's say we have a lot more inheritance going on, like just kind of a lot more. Um, would you just have to write it like on a test page? You just have to write assert existence for like all of them. There's no kind of, I guess, blanket statement kind of thing to just kind of test for the inheritance of like, let's say you do for lead engineer, just able to put like front end developer and scrum master, and then that also is going to check like kind of intuitively for tech job and manager. So we're just going to have to just write it down line by line.
Yeah, so if like right here we're explicitly testing each thing, you could maybe make the argument that these tests are not really necessary because they're being tested here already. So you could make the argument that these are duplicate tests. But I don't.
Okay. Yeah. Okay. That makes sense. Kind of thinking about that.
Because we have a unit test for like tech job, for example. So tech job is already checking if tech job is an instance of job. So for front end developer, you could argue that if it's an instance of tech job, you've already tested that tech job is an instance of job. So that's kind of a redundant check.
Okay. Makes sense.
Okay. So we have the basic skeleton. So let's look at actually filling some of this in. So I'm gonna, this is gonna be very basic, kind of like the minimum we need to get something working. But I'm gonna say that, a job, the whole point of it, the most generic thing about a job is that, you get paid for it. So I'll write a method that get paid. So, and we could make up anything here, but I'm going to say that you also have something called salary. So any employee, but like any job should have a salary associated with it. I'm just making this up, but self dot salary plus equals 1. I'm just making this up, but so now we have to give job a salary property. So how do we make job have a salary property?
You gotta initialize it.
Yeah. So we'll do that in init. So def init self, and I'll just say self dot salary equals 0. There are a number of ways we could do this. Here, if I create an instance of job, I don't actually pass this in. This is just gonna exist here. I could make that a dynamic value, so you could determine that when you create an instance of job. So salary, and then I could do equals salary. You could do that as well. It just, I'm just making this up, so we'll do this for now. Okay, so I just made some changes. So I want to run my unit test again. My unit test pass. I could also add another test, for example, that job has a self.salary property or whatever, and that it's 0. It's the value that I'm expecting. I'm not going to do that, but so you can keep writing more tests to describe whatever you're writing. Okay, so that's job, and then tech job. So tech job needs to inherit from job. So def init self, and then I'm going to say tech job. I'm going to say this has like a specialty or domain. I don't know. Self dot domain equals domain. And then I'm also going to override this get paid. So, a tech job is going to get more than just a generic job, let's say. Def get paid. So I can just override this entirely. So self dot salary plus equals 100, something like that. And if I run this, oof, we got a failure. So I don't think I did anything in particular wrong, but what happened? So the init, it's telling me where this error is occurring. It's in test.py, line 11. So I can jump to that. So here we are on line 11, and I need to give this a value. So this is going to be special, let's do whatever that is. Okay. So now we have a whole bunch of other issues. So we made one change here, but now we're getting an error here with lead engineers. Actually, several tests are now failing. So we've got an issue. So what I'm going to do is I'm just going to comment out these other tests for now. So now this passes, but if I try to do this one, we've got this problem. So to diagnose what's happening, one thing that I'm gonna do is I'm gonna run some ad hoc tests. So I'm gonna create an instance of tech job, and I'm gonna make sure it has the properties that I expect. So
Are the other classes trying to inherit domain from TechJob?
yes, but which other classes?
Well, I guess the classes that inherit from TechJob.
Exactly. So when you create an instance of tech job, it's expecting a parameter called the domain. And here we don't have that. We'll have to figure out how to make that happen.
And also, Chad, is the reason that we didn't need the super is because there's no I guess parameters passed in I guess the init for the class job. So when we created tech job and that's inherited, I guess everything from job, we didn't have to like go super and all that. Is that correct?
Yeah, so we'll take a look at that just to make sure that that it's doing what we expect. That's kind of why I want to create an instance here, and then let's take a look at the salary property. So
Okay.
ooh, okay. So this is not what we would expect, right? So I have this tech job class which inherits from job, and I know that job has salary, right? So tech job should also have salary. In fact, I refer to it right here. But when I actually create an instance and I try to take a look at it, it's telling me that tech job has no attribute salary. So what's the problem here?
I would think we do need to use super to get the init or to get what's in the init of the job class passed to tech job.
Yeah. So, this is just how Python does it. But you have to explicitly call the init method of the super class. One way of doing that, super init. So now let's run this and see if it works. So now that works. So what we're doing here, this call to super is basically the same thing as calling job, because that's what's right here. So we could actually replace this super call. We could do job, and then we have to pass in self. That's just how it is. If you do this, you should get the same thing. So super is kind of it's just a way of calling this class directly. So we're calling the init method of the superclass. So the superclass is job. We're calling job's init method. And once we call that, then we have access to everything that's in the job's init.
But it hasn't overridden the salary yet. Because when you run the test, it returns 0 instead of 100.
Exactly.
You actually say salary or techjob.salary.
Yeah. So exactly. So what we've done here, so tech job, once we call the super's init, has access to everything in the init, which in this case is just salary. But salary is 0 because it's accessing the parent class's init. So tech job is gonna start off with a salary of 0 because that's what its parent class has. So what's gonna happen if I call get paid on tech job?
Salary should equal
Now we should
100.
get the salary of 100.
Yeah, so let's try that. So I'm gonna go tj dot get paid. We should see 100 there. And what if I don't override this? If I call, yeah, so run this again, and I get 1. So what happened here is I create an instance of tech job. I say, hey, tech job, call your get paid method. The interpreter looks here and says, there's no get paid method here, but I have another chance. So I can look in this thing as well. So it looks in here and it sees get paid and then it calls it. And this increments the salary by 1, which is why it's 1. So again, I think thinking about this in like 3-dimensional terms, where this class is really on top of job. It's kind of like if you've ever done any like photo stuff, you have things in the background and things in the foreground. So you can put a picture on top of another picture. You can, push it down so it's at the bottom or whatever. So that's what we're doing. If we define get paid, now we can also do something else, which is we can also call. So we're overriding the get paid method of the parent class. We can have direct access to that. So I can call super dot get paid. Now, if I call get paid on tech job, what is the salary going to be?
Will be 101.
Let's see. So even though
I
we're
actually thought it would print
overriding
it
it,
out twice.
how's that?
Sorry, no, I thought it would print out 1 and then 100, but it kind of adds it already together. Okay.
Yeah. So this get paid method, all it's doing is incrementing this salary. So it's not actually printing anything out. So all it's doing is incrementing this salary. So we call get paid on tech job, and it calls this, which means that salary is now 1. So after this line, salary is now 1. Then we call this line, now salary is 1 plus 100. And then that's it. And then I'm printing the value of salary at the end.
So you could use the super almost as like as an input, as a variable then. Like you could write another method in there under the get paid for tech job, like that, uses whatever calculation, for instance, HR would use to calculate a tech's salary, and you could input that into the self.salary or.
Yes, yeah. So you can do whatever you want here. So we're overriding it. So from the outside, when I call get paid on the instance, it's going to call this, and it's going to not even know that this exists. However, I also can have more fine-grained control. So once I'm in here, I can then call this. I can also, instead of super, I can do job, and then I pass in self. And this will give me the exact same value.
So, a quick question.
Yeah.
Does super always refer to like the base parent class, or is it just like the next inheritance class up?
Yeah, so it gets tricky, especially with multiple inheritance. So we'll see that play out in a little bit. Okay. All right. So we've now got this one. So let's do one more, and then we'll take a short break. Let's do front end developer. So a front end developer is going to inherit from tech job. So if we want front end developer to have the domain, which I guess it's going to have, and also a salary. So we're going to have to take care of that in the init. Self. And then I have to have domain, because that is coming from tech job, which requires domain to be initialized. And then I can add something else. I can do language. So I have to call the init here. So super init. And then I'm calling the init for tech job here. So what does the init for tech job need?
Domain.
Yeah, it needs domain. So I'm going to call it with domain. And then this guy can just get used right here. So self dot language equals language. And
So
then
if each super class had like a domain, like if it had another parameter in there, would you have to list all of those then under, I guess, under the super in it as well?
yep, so if
Domain, comma, whatever, the parent class had, that sort
yeah,
of thing.
yeah. So this call to the super init, it's just a method, right? So if this method takes one parameter, you have to give it a parameter. If it takes 5 parameters, you have to give it 5 parameters. And then I'll also override this one. So now I'm going to create an instance of front-end developer. And this is going to take the specialty and then the language Python. Everything else should work. And until we get 1,000. We create an instance of a front-end developer and then call get paid. We've overridden this. And we should also have access to domain and salary. So we've just checked salary. Let's do fe.domain, fe.language. So front-end developer has access to everything in tech job, which has access to everything in job. All right, let's take a 10-minute break and when we come back, we'll finish looking at this. All right, so we've got implementations for job, tech job, and front-end developer. So I'm going to just add one more method to front-end developer. So def write code self, and then print writing code in self dot language. So now if I also call fe dot write code, I can still, a front end developer can write code. If I try to do that with tech job, so now let's just do tech job. I get an error. So tech job has no attribute write code. So front end developer can write code. Tech job cannot write code. All right. So at this point, let's try to run our tests again. Let me comment this out. Okay, so we have an error. Let's look at the tests. So we have an error test line 15, which is right here. So we're trying to call front-end developer. It's missing 2 required positional arguments, domain and language. So let's do domain and let's do Python. So now if we try to run these tests, they pass. So we're good there. And let's go back to our manager and try to run that test. That test passes. So We can do a little bit more here. So for manager inherits from job. So we're gonna do the same thing we did basically for tech job. I'll just copy this.
I got a quick question, Chad.
Yeah.
So say you want to skip over the tech job salary and you just want to add the front end salary and say there's some base salary for job. So if you put in job or say you do the super get paid for front end developer.
Yep.
And then you call just job for get paid.
Yeah.
Will it skip tech job?
Yes. So we can do that real quick. So job dot get paid self. So what are we expecting the salary to be if we call get paid on front end developer?
1,001.
Yeah. So we'll test that out real quick. So front end developer. Doesn't even matter what it is. And then it's called get paid, and then we will check the salary. So 1,001. Whereas if you instead of calling job.get paid, you did super. It's going to call the super is basically a convenience method for calling this guy. And tech job calls its super, which is job. So it's going to get +1, and then it adds 100. So we get 101. So it's
Okay.
plus 101.
Okay. So if you did lead engineer the same way and then you just wanted to start at tech job, it would skip front end and bubble down to tech end job.
Sorry, can you ask that one more time?
Yeah. So say if you do the same implementation for lead engineer, and then you call the get paid starting at tech job, would it bubble down to it would skip over front end and then bubble from tech job to job
Yes.
as well. Okay.
So if you explicitly called the tech jobs get paid, it would jump directly to there, and that one also calls jobs get paid method.
Got it. Thank you.
Okay. Just comment that out. Okay, so we're on manager now. So manager, I don't know what could a manager take? Department
org.
Yeah. So now if I want to create an instance of manager, so let's look at the tests. So if I try to run the test now, that's gonna fail. So we have to make this pass, we have to give it a parameter. So fails, whatever. And now the test passes. Let's just say for manager that a manager is gonna, not realistic, but a manager is gonna have a job salary. So we don't have to write an implementation. We don't have to override each method, right? So I can just not implement get paid for manager, and manager will use jobs get paid method. I'll just leave that. And I'm going to add another method here. So def manage. So So if I create now an instance of manager, I need to pass it a department. So sales. And then I can call get paid. And what is the manager's salary going to be?
1.
Yeah, because it doesn't have its own overridden. So when you call it, it's going to look here, up, doesn't find it. So I'm going to look in job, and here it is in job, salary plus 1. Okay. So I can also call manage. So F dot manage. And that's available there. Okay, so let's move on to Scrum Master now. So Scrum Master def init self, and because it inherits from manager, we have to give it a department. So department, and then let's do certification. And what do we have to now do inside the init of Scrum Master?
Kind of super.
Yeah. So super, we have to call the managers init so that we get self.department. Super dot init department. And then we can carry on as usual. So self dot certification. And then let's override the get paid method. And we'll get paid a lot. So now I'm going to go back and look at the tests. So I want to test the Scrum Master again. So running tests. That fails. Which test fails? Line 25 in Scrum Master. We're missing 2 positional arguments. So fails and add hopefully that should pass. Does pass. Okay, so now we have the final note here. So def init self, and we have to take care of the front end developers init. So front end developer needs domain and language. And then Scrum Master, and Scrum Master needs department and certification. So it's a little tricky here because we have 2 classes that we call super. We try doing that. Let's just call it all this stuff. Oops, super dot init. And let's just say we don't need to add anything else to this one. So I'm going to uncomment out the test here and try to run it. And it fails. So I got to add, I'm just going to do 1, 2, 3, 4, and I'm lazy. And try to run this again. And now it's failing with a different error. So where is this error happening?
is it all the redundant tests for tech job manager? None of them are getting the domain language department certification passed through.
Yeah. So yeah, so that's a good thought. We'll hold on to that for a second. But first, just looking at this error. So can someone tell me how to read this error?
It looks like on line 50, we're calling our init super with too many arguments.
Yeah. So just in terms of reading the error, notice we have two, looks like there's like two errors or something. One thing is happening on line 50 of jobs.py, which is right here. And another thing looks like it's happening on line 30 of tests. So why am I getting these two different spots?
Because since we're only using super once, we're trying to pass like four
So,
parameters.
yeah. So I'm trying to get people to tell me what is the structure, like ignore the specific error, the structure of the error message. Why am I getting two different locations?
The line 30 in test is what ran before the line 50 in jobs.
Exactly. So notice that this is called a traceback. So it's an error trace. It's not just an error, it's a trace. And it says most recent call last. So what happened was it tried to call this, right? Test.py line 30. So it tried to call that. And while it was calling that, so this, obviously calls this, which calls this. And here's where I actually get the error. So the bottom line is the most kind of immediate proximate cause. So if you're looking for the error, like here's where the actual error occurred, but you can also trace it back. So it got called here, but it got called by this. And you can have, lots of levels here. So, when you get an error message like this, it's the most recent call is last. So first it called this, which called this, which threw an error. Okay. So now that we kind of know the structure of the error message, the message itself is blah, blah, blah. So the init takes 3 positional arguments, but 5 were given. So I'm trying to call this super init. So what is the super in this case?
The front end developer.
Yeah. So the supers, so there are complicated rules, blah, blah, blah. We don't need to worry about that. But it's basically the first thing listed is going to be the super. So front end developer, we jump up here and we see that it takes, a couple things here. So we're trying to call this, but we have too many things. So we really need to initialize both of these, but we're doing it with one super call. So how does Python know which parameters go where? And I don't. There may be some tricky thing you can do in Python, but I think this is basically just not going to work. So we're gonna have to take a slightly different approach, and we're gonna have to individually specify which inits we want to call. So we're gonna get rid of the super, and we're gonna explicitly call front end developer dot init, and front end developer needs what? It needs domain and language. And you also have to pass in self when you do it this way. And then we're also going to call Scrum Masters init. Self, and Scrum Master needs department and certification. So now if I try running this, basically works, but now we have another problem. So once we leave the realm of super, we kind of have an issue. So if we go back up here and then manually specify all of these, so manager, give it self, I'm gonna call job self. Job. Try running this again. And now they pass. So now they all pass. So super is it's a nice convenience, and there are a couple benefits to using it. But when you start doing stuff like this with multiple inheritance and multiple inits with different initialization parameters, then I think this is really the only. Again, there may be some trick that I'm not aware of, but I think this is kind of how you have to do it. So I'll say that there's kind of I'd say the consensus view is that multiple inheritance is not a good pattern to use. It makes things kind of complicated, but it's definitely out there.
Would you say like even when dealing with like not multiple inheritance, that like it's probably just better and easier to call things explicitly, so like you don't have to guess where super is, like if you're not familiar with the code?
Yeah, so there's that's kind of a style question. So people will give you different answers if you ask them. So one of the benefits of using super, so here I'm specifying job, blah, blah, blah. But what if I change the name of this to position? Well, now I also have to change this. So if I just use super, it's more generic and it will just dynamically take care of that for you. But once I am explicit, I have to be explicit all the time. So, there's some drawback to that. Some people would argue that, explicit is better than implicit. That's kind of a Python. There's a whole there's something called the Zen of Python. And so there's kind of like the philosophy of how you should write Python, which you don't need to pay attention to, but that's one of the maxims. Explicit is better than implicit. But in this case, I think we're kind of obliged to do it this way. But aside from the the syntax, this is basically how you would structure something like this. So you think of a design. Ideally, you get some kind of visual representation to help keep you sane as you're mired in the details, and you write tests that describe the basic behavior that you want, and then you can implement code, and then as you're writing code, you can make sure that you're not breaking something else. Are there any questions about that?
So do you see more class child swapping or adding multi-level inheritance on a project to kind of add to what Philip was saying?
Yeah, so it depends on it kind of depends on the language and also the I guess stylistic preferences of the developers that you'll be working with. So another way of doing something similar, a different approach, is instead of using inheritance, you use something called composition, which we'll talk about next week. And composition is a little more flexible. So composition is basically, instead of specifying like, tech job is a job, front end developer is a tech job, you basically make it a has, instead of an is a relationship, make it a has a relationship. So you would give front end developer whatever, if you want front end developer to have tech job methods, you just pass in, you either pass in an instance of like tech job, or give it, you basically create classes that have the functionality that you need, and then you combine them. You just use them in a particular class.
Okay.
So it's a different way. That's kind of I would say, that's basically the preferred way of doing it. But you will most definitely see lots of, complicated class hierarchies, especially if you're working with a language like Java or something like that.
Got it. It seemed like if you were to use the composition way you were doing, it would make sense to set it up not using super, just in case you wanted to implement multi-level inheritance for future purposes, I guess.
Yeah. Mm-hmm. So you guys will be exposed to composition next week. So this is one way of doing it. It kind of, it kind of reflects the structure for certain problems. It basically reflects the structure of the problem pretty. There's like a one-to-one correspondence between the code structure and then the structure of the thing that you're working with. So it doesn't, you don't have to always do that. Like, a solution that you build doesn't have to like mirror the structure of the problem exactly, but in this case, it does. All right.